Alright, so here's your P8 solving inequalities. I'm going to start off by doing an absolute value one. So we're going to solve by graphing and algebraically. You can look at this and realize that that's a right one up to. Remember, absolute value looks like a V, right? And we have an initial slope of 2, so we're going to rise 2 and run 1 both ways. Here's my absolute value guy. The other guy is in the form of mx plus b. Remember that old thing? We have a y-intercept at -3 and a slope of 4, so we rise 4 and run 1, rise 4 and run 1, rise 4 and run 1, somewhere up there. Now, what is the question asking? And this is a hard skill for some kids to realize. What is this thing even asking of you? It's asking, where is the v, because the absolute value equation, less than, which means below, or equal to, which means intersecting, the line. Okay? And that is this particular region of space here. And, you know, looking at my graph, it's somewhere before 2. So if I was just looking at a graph, I would say that x is greater than or equal to roughly about 1.7. That's an issue with graphing, okay? Now, contrast this with algebra. The issue with algebra is it's probably going to give us 2 answers, right? That's the issue with algebra. The graph says there's only 1. So the 2 have to go hand in hand. Sadly, they do. All right, anyways, let's do this algebraically. One thing I'm going to do is I'm going to go ahead and subtract 2 before I write anything down here. 2 absolute values of x minus 1 is less than or equal to 4x minus 5. Now, the very first step in solving absolute value equations is an isolation technique. Get absolute value by itself. I'm just going to go ahead and move that 2 in. That way I'm not dealing with fractions on the right-hand side, because if I was to divide by 2, I'd have a fraction here. And I don't really want to work with fractions. It's too early in the morning for me. So I just play the avoidal game. Avoid them as long as possible. All right, now that I've got absolute value isolated, I'm going to write 2 equations. One of them is as is, drop the bars. In the other one, I change these guys' signs. Not a hard skill. Then I do algebra, right? I'm actually going to be shifting my x's right and my numbers left. Because 4x take away 2x is 2x. Greater than or equal to, -2 plus 5 is 3. Divide out my 2, and I have that x is greater than or equal to 3/2. Now you should know 3/2 is 1.5, and that's my answer there. This guy down here is going to be a junk equation. Still going to move my x's left. I'm going to have 6x. If I add 5 to 2, I'm going to have 7. And I'm going to have x is greater than or equal to 7/6, which is not a whole lot over 1. So the 3/2 is the answer. The graph is suggesting that's the best one to pick. This one's junk. And now I can write my interval notation. So the interval would be that I am greater than or equal to 3/2, which means I start at 3/2 and I run right to infinity. Set builder would be all values of x such that x is greater than or equal to 3/2. And there you go, there's number 2. Alright, moving forward, do one more graphing one. Which one do I want to do? I guess I'll probably do 4. 4 could be interesting. We got 2 absolute value equations. We have a right one up 2 situation here. Right one up 2, change keep. Fall 2, run 1. Alright, on the other equation, we have a down 2, left 4. And we have a slope of 1. So, you can clearly tell that there's not a single solution to this thing. Now, is there? There is not a single solution to that. and you would not have seen that algebraically. But there are no frickin' solutions. And we're going to do the algebra. And you too are going to do the algebra so that you will get it in your head that you can't trust it. You got to have a picture because a picture's worth 1,000 words. Anywho, on to the algebra. I'm going to isolate the guy on the right. That's going to give me negative 2 absolute values of x minus 1 plus 4 on the left. Now I'm going to write two equations. I'm working with this thing, okay? That's the thing that I'm going to base my two equations off of. And I'm just going to drop my bars. They're going to become essentially parentheses. Alright, what's going to be on the right here? Less than or equal to x plus 4. That's one of them. Or negative 2 parentheses x minus 1 plus 4 less than or equal to negative x minus 4. Alright, so use the distributive property here. Negative 2x minus 2 add 4 is less than or equal to x plus 4. I'm going to shift my x's right. X plus 2x is going to be 3x. On the left there's a 2 here because negative 2 plus 4 is 2. And then 2 minus 4 is negative 2. And I get that x is greater than or equal to negative 2/3. Which is just gibberish again. Look at the graph. Over here, invoking the distributive property, that should be a plus 2, shouldn't it? That'd be 6. Okay, that's positive. Positive. Okay, 2/3. Made a slight mistake there. Anyways, fixing that. Negative 2x plus 2 plus 4 less than or equal to negative x minus 4. And again, I'm going to shift my x's over here. That's going to give me an x on that side. And 2 plus 4 is 6. If I add 4, I get 10. It's saying if x is greater than 10, this is true. And it most certainly is not true. The graph is saying there are no solutions. So, the moral of the story is trust a picture over algebra. Trust a graph over algebra. Of course, the graphs have their shortcomings. It's hard to get an exact answer from a graph, right? Make sure you get that. Like, what's more important? The picture. The picture is the big deal. You want to see the picture of things. So that's why graphing is important. All right. Solve algebraically. Decide if you can trust the answer without referring to graph. I can tell you wholeheartedly if it involves absolute value, maybe. Like that's what it is. That's the deal. If it involves absolute value, maybe. All right. So anyways, you're supposed to do these, and regardless of whether you can trust them or not, write your answers using interval notation or set builder. It says use set builder or interval, regardless of the trustworthiness of your answers. And I don't really care to do a whole lot of these because by and large you need to be doing most of them. So I'll do like number 7. And if I was looking at number 7, the first thing I'd probably do would be the distributive property. That would give me 6x minus 15 plus 4 less than or equal to 4 times the absolute value of x minus 3 plus a 2. And we're going to do some cleanup operations. Like I'm going to subtract this 2 over here. So I have a 6x, a negative 15 plus 4 is negative 11, and if I take away the other 2 I have, I'd have negative 13. Still less than or equal to 4 times the absolute value of x minus 3. Now I could divide both sides by 4, but I'm just going to move that 4 inside because I'm going to avoid fractions as long as possible. And now I'm in a position to write my two equations. My two equations, one of them is 4x minus 12. Oops, I don't know why I'm starting on the right side first. One of them is 6x minus 13 less than or equal to 4x minus 12. Or the other one is still 6x minus 13, but this time it's less than or equal to negative 4x plus 12. And then we just do algebra, right? 6 minus 4 is 2. Negative 12 plus 13 is going to be a half. I'm sorry, I'm a step ahead. Negative 12 plus 13 is 1. And if we divide out the 2, x is less than or equal to a half. All right, other dude. We add 4x to 6x and we get 10x. We add 13 to 12 and we get 25. And we divide by 10. And we get that x is less than or equal to, both 25 and 10 are divisible by 5 halves. So what's interesting here is that you're less than a half and you're less than 5 halves. Okay, this is the winner. That's the bigger deal. Because think about this on a number line. Okay, you got a half, and it's saying I'm less than that. But then you go out to 5 halves, which is 2.5, and this guy's saying less than that. That's the one that wins. So if you're less than or equal to 5 halves, you're everything from negative infinity to 5 halves. If you like set builder, all values of x such that x is less than or equal to 5 halves. You know, inequalities in themselves, when you use your less than equal and your greater than equal sign, they're basically set builder notation as is. But anyways, if you see absolute value, don't trust your answer. Like that one, it had 2. I know that it was probably this one based off experience. All right, solving zeros using the zero product property. The zero product property, one of the most important properties in Algebra 2 that a lot of kids just refuse to accept. Like, you don't want it to be true. So the idea is if A times B is 0, then A equals 0 or B equals 0. Like, that's literally the zero product property. So here I have the product of two things. The first one's A, the second one's B. So, and they multiply together to be 0. So this means that 4x minus a 7 is a 0. Or, and hear me out, x minus 5 is a 0. And these are both simple equations. On the first one, you just add 7 to both sides, and then you divide out your 4, and you get x is 7/4. On the second one, it's a single-step equation, which every year I have a lot of kids who can't solve a single-step equation. I don't know how you breathe. Like, I haven't quite figured out. Like, if you can't solve x minus 5 equals 0, like, how are you able to do anything at all? Like, I'm really highly confused by you. Like, you need to work on that. You do. You need to fix that. It's a big problem. Anywho, and I'm not going to do a whole lot of your homework. I'm going to do number 14. A line passes through the points -1, 3 and is perpendicular. So I see that keyword perpendicular. And every time I see the keyword perpendicular, I think opposite reciprocal slopes. Opposite reciprocal slopes. So, I've got a line given to me. It's 5x minus y equals 7. I'm supposed to be perpendicular to it. So I'm going to make this thing look like y equals mx plus b. I'm thinking y equals mx plus b, because I can steal slope from y equals mx plus b. So to do that, I move the 5x to the other side. And again, if I'm going too fast for you, just slow the thing down. And then I'm going to divide out the negativity. And I realize that it has a slope of 5. Okay? So the perpendicular slope is the opposite reciprocal, which is -1/5. Alright, now you can use point slope form, or you can use a form we've been using in class a lot. I'm going to use y equals a times x minus h plus k, where a is a slope and h and k are a point on the line. I know that the slope is -1/5. I know that h is a -1, and I know that k is 3. I also know that taking away a negative is addition. It always has been. It always will be. It will not wake up tomorrow and change its mind about what it is. And I'm also aware of the distributive property. So if I do a -1/5 times x, I get -1/5 of x. If I do a -1/5 times 1, I get -1/5. And then I have the plus 3. Alright, so you go old school, -1/5 plus 3. 3 would be 15/5, perhaps. And you get 14/5. Who would have thunk that 5th grade math is still sticking around, okay? Who would have thunk that? It's not so much that kids are bad at Algebra 2, I've noticed. It's that they're just bad at 5th grade math in general. And there you go, kids. Assuming I didn't make any mistakes. If I did make a mistake, please do not blindly copy me. Please figure out what the mistake was and fix it. And you can even laugh at me and be like, ha, you made a mistake. I don't care. I'm a person. I make mistakes. And you learn by making mistakes. Anyways, there's the homework I'm doing from that particular section. Later.